Okay. So as far as this review goes, these questions like you had here where you're just adding and subtracting integers, I didn't actually put those on there because you pretty much do that again when you do things like evaluate an expression. So I'm going to skip number 1 here, and I'm going to really just start here at number 2. Well, let's hope it's going to make my screen bigger, but it looks like it doesn't want to do that. So you do have at least one question that is one that has to do with evaluating an expression. So if you remember when we're evaluating expressions, this is where we're going to be doing this order of operations. In the order of operations, the first thing we looked for was parentheses. Okay, I spell it close to parentheses. So what we have to do is just rectify what's in the parentheses. So if we do that, we end up with 6 minus 1, we have 5 squared. So then the next part was exponents. So we try to deal with exponents. Then after exponents was multiplication and subtraction. And though it doesn't really apply to this one, just want to point out here that when we do multiplication and subtraction, it's the first one we do is from left to right. So we really only have one multiplication or subtraction, sorry, multiplication or division. We only have one example of multiplication and division. We don't have a couple we have to deal with here. So we just have this 4 divided by 2. So that is going to leave me with a 2 plus 25. Then we do adding and subtracting. Once again, we do that left to right. In this case, we only have one to worry about, so we don't have to worry about the left to right. So now we know this whole thing all adds up to 27. Okay. For the sake of time, I'm just going to tell you right now, I don't have one that's set up like 3. It's going to be something like maybe 2 or 4 along those lines. So I didn't worry about having the one with a quotient. I was trying to keep this down, so I was really covering like maybe 1 or 2 problems in a unit. It came out to 19 problems. Okay. So I'm going to scroll down to 4 here in a second. So one more time, to simplify, so basically we're using order of operations again. I think I was missing a letter here in parentheses, but we got parentheses first, so we deal with everything in the parentheses. So we have 10 minus 1, so that's just going to become 9. And then that square stays out here. Then we have 2 sets of parentheses here, so we do the inner one first. So if we do have them stacked, it's always the inner one first. So the inner one is 2 plus 7, so that's going to just be a 9. So then we keep on going, and now I have to deal with the other parentheses. So dealing with these parentheses, the first thing you're going to do is exponents. So like I said, I'm just dealing all within the parentheses right now. So exponents, 9 cubed. Let me just double check that. In my head, I thought I had it. Then I was like, am I right? 729, and then we're dividing by 9. Then we're going to do the multiplication / division, whichever we need to do. And then we would do addition if we had it, but we don't. So we end up with just 81 in here. So then after that, we can go back out here and we're going to start over. So let's say this was A and B. We're going to start back over now at 2, which is we're going to do exponents again because now I dealt with everything that's in parentheses. So we have this one here. We get 81 times 81. We don't have exponents anymore because we dealt with that. So we just have multiplication or division. And then here we get, what is 81 times 81? $6,561. So just so you know, on your test, none of them are going to have answers that are this large. Like I said, I try to do most of it that you could do it by hand and not have to need a calculator for it. We do have a question like 5 or 6. So this is evaluating an expression given some values. So this first one is we have b squared minus 4ac, and we know all our a's are 2. All our b's are minus 7. So remember that's minus 7 squared, and then my c's are all a minus 7 as well. So just as a reminder, because this is usually where I see things go wrong. So the minus 7 squared, so you're squaring it. So that should come out to be a positive 49, not a negative. Once again here, we have, this is going to be 4 times 2, so we're going to have 8 times negative 7. So negative 8, negative 7. It's going to turn into a positive. That's 105. So evaluating expressions, like I said, the biggest problem I was seeing on that was just not being careful with your negatives. So if we did this one here, this says minus 8, and then we have an x that's squared, and then we have a 4 times another x plus a 2, and all of those x's are being replaced with a negative 1. So this is minus 8 times negative 1 is squared. That's just going to be positive 1. Minus 4 times minus 1. This should be plus 4 plus 2. So negative 8 times 1 will just leave me with a negative 8. 8 plus 2 is 6. Sorry, 4 plus 2 is 6. Minus 8 plus 2 is negative 2. I got to check this to make sure somebody wasn't asking a question. Nope. So this first stuff I'm going to go through a little quicker so we can spend a little more time on the other things. Okay. I might have to skip around on this test a little bit because your test is a little more organized than the review came out to be. There are some questions about improper fractions to mixed numbers and mixed numbers to improper fractions. I really only have one of these. So it's either going to do a mixed number to improper fraction or improper fraction to a mixed number. Okay, so improper fraction to a mixed number. So in this case, what we did is we would take the 20 and then we divide 9 into it. So here we see 9 goes in 2 times, which leaves me with a remainder of 2. So my mixed number would be, this is my whole, and this is my new numerator. I end up with my answer would be 2 and 2/9. When we had a mixed number, when we write it as an improper fraction, this one was a little easier one because we had this method that said, I'm going to take this number and I'm going to multiply it to this. So we're going to have the 6 times 15. And then whatever that turns out to be, we add it here. So we're going to add it to that 2 on the top. And we still keep the denominator of 15. So 6 times 15 is 90. Add a little crooked here, just a second. So this ends up just being 92 over 15. And as I said, if I gave you this one, it'll be much smaller numbers. You won't end up with a 92, hopefully. Then we had some adding and subtracting of fractions. And we had multiplying fractions. And we had division too, right? Yeah, okay. So this part actually leads us to a second part of fractions, which is equivalent fractions. Is we had to find equivalent fractions so that we could multiply these. Or add these, sorry. Find equivalent fractions with the same denominator. So this only applies to addition and subtraction, though we need to find the same denominator. So we had 2 methods for this. So there was method 1, which is basically doing this, is I'm going to take this 10 and multiply to the top and bottom here. So I got 1 over 8 times 10, and then the bottom's times 10. Then I would take this 8 and multiply it to the top and bottom of the other fraction. So I ended up with 7 times 8 and 10 times 8, because now what I'm going to have as a denominator is going to be 80 for both of these. So we have, oops, not 80 on top, 80 on bottom. We have 10 over 80. And then we have 56 over 80. At this point, I can just add the tops together. And we end up with 66 over 80. So remember, when we have equivalent fractions, that's because they all reduce down to the same fraction. So 10 over 80 and 1 over 8 are equivalent fractions because I simplify them down both to 1 over 8 if I needed to. So this one, once again, we have to find an equivalent fraction. We have to simplify. So we can divide the top and the bottom at least by 2. We end up with 33 over 40. I don't think we can do any more than that. So that would end up being our answer. So we just want to make sure you write it in lowest terms. So I'm going to write this down here. This is the other method. This is the one I think you guys probably were using the least. Is where we look for something called a GC. I'm trying to remember if we use GCD or GCF because it changes every time I do this. Like every book gives me something different. It was GCD or GCF. So basically we were looking for the largest factor of both numbers. And this method just takes out the chance that we have to simplify later. So in that case, we had the denominators of 8 and 10. So we're just looking for, they're just looking for divisors of each of these. So this one has divisors of 1, 2, 4, and 8, or all the numbers that divide into 8. All the numbers that divide into 2 are 1. You know what? I was looking for the wrong thing here. I meant an LCM. I don't know why I said GCD. GCD was for something else. I think because I had another class telling me that every time I try to do this, I was doing a GCD. It's an LCM, least common multiple. So we had a denominator of 8 and a denominator of 10. So multiples of 8 are 8, 16. Just a second. 8, 16. Then we would have 24. Then we would have 32. Then we'll have 40. We keep having more of them. Multiples of 10 would be 10, 20, 30, 40. So that is the numbers that I'm looking for, the smallest common, or the least common multiples of both numbers. So I'm going to finish up that method up here. So the whole point of this is that I want to know, what do I have to multiply 8 by to end up with 40? Because basically we're saying that this is going to be my new denominator. So what we see is 5 would work for that. If I multiply 8 by 5, I'm going to end up with 40. So I have to multiply the top by 5. And then the same thing here. What do I have to multiply 10 by to end up with 40? Well, I'd have to multiply by 4. So I have to do the same thing to the top. So I end up with 5 over 40 plus 28 over 40. If I add those together, I'm going to end up with 33 over 40. Okay. So the one I have for 10, I actually made a little easier than what we have here. But like I said, we need to find equivalent fractions of the same denominator only when it's addition or subtraction. So we're going to bring up these two here together to look at. So if we want to multiply these two numbers, we want to first turn this to an improper fraction. So 3 1/3 as an improper fraction will end up being 10/3. And then we'll still keep 1/10. So when you multiply, all you have to do is just multiply the tops together and multiply the bottoms together. And then to make sure you simplify. You have division. We said that we can turn division into multiplication. And all it required was to just change this part here. So we'd keep that 1/6, but if we want to turn it into a multiplication instead, we said, instead of saying divide by 10/7, we say we multiply by 7/10. So we just flip that last number. Once again, we get 1 times 7 on top, 6 times 10 on the bottom. You end up with 7/60. So there are one or two, I'm trying to remember exactly how many I put on here, but there are a couple problems where it was converting a fraction to a decimal or a decimal to a fraction or any of that stuff that we did. So really just want to run through one example of each that we had. So we want to convert 1/3 to a decimal. So one thing, you do have calculators now, so that will help you. But one of the things that we had said, if you didn't have a calculator, you're taking 1 and you're dividing it by 3. So we can't get 3 into 1. It doesn't fit in at all. So what we did is we basically like put a decimal here. We pretend there's a decimal here. But put a decimal here, and then we're going to make this into a 10. So we're just expanding the place value. 3 goes into 10 3 times. And that leaves me a remainder of 1. Well, because I still have a remainder, all I'm going to do is I'm going to add another 0 here. It drops down, comes down here. 3 goes into 10 3 times at the least. And we basically keep repeating this over and over again. So what we see, and somebody was asking me about this, about these bars. I didn't put that on your test. But we see that this one is 0.3 repeating, or you can say 0.3333. But I made your test multiple choice. You don't have to find a way to enter that in there. You just have to be able to select the right answer. We want to write a decimal as an equivalent percent. This part's going to kind of kill 2 birds with 1 stone. So when we had a decimal and I wanted to write it as a fraction. Oh, actually, sorry, we don't need to do that part. What we need to do this is that if we had a decimal, 2%, then we would move the decimal place. That the wrong way, decimal to percentage, percent to decimal, is that we would take the decimal and we would write it in this direction 2 places. No, I had it right the first time. I don't know what I'm thinking here. I got myself confused somehow. 2 places. Decimal 2%. Yes, I don't know why I keep reading as percent to decimal. If we had percent to decimal, then we would take that decimal place and we write this direction 2 places. So from here, I just need to go back 2 places with that decimal, and that's going to just leave me with 73%. So that leaves us with this one here. Will still apply to this same part right here. My board just gets slightly off kilter. So 7/10, we talked about this as I'm trying to convert numbers like this from decimals to percent. So we said basically how many zeros you had here. If you had 1 and then you was followed by 1 0, that means your decimal place would move up 1. If I had, say, 7, but it was divided by 1,000, then that means that we have to move the decimal place up 1, 2, 3 places. So there's 2 places before the 7. So I know that 7/10 is just going to be 0.7. So this is as a decimal. So if I want to write as a percent, that means that because I'm going from decimal to percent, I'm going this way once again. And that's giving me 70. So I kind of worded some problems where it's not necessarily you're looking just for like straight for one decimal, I mean like one answer here. So a lot of these are like you might have a decimal and you want to write it as a fraction, but you have like a couple fractions to select from, so you may have 2 answers. Because once again, like sometimes when we do these, we get an answer and then the answer simplifies. So I kind of left it so you get one of the answers and then you'd have to find the simplified form. So like I said, some of these may come up with multiple answers for them. Okay, so sets. All right, we'll make sure this is what I wanted here. We had unions, which we said was all numbers, so everything. So a union was all numbers in both sets. And then we had an intersection. And this was only numbers shared by both sets. So this symbol here, if you remember, this means union. So A union B, and these are our 2 sets, we have to write down all the numbers that are in both sets. So in that case, we get 1 because we have a 1 at least once. We keep 2 because 2 appeared at least once. We have 3 because it appeared at least once. We don't have 4. We don't have 5. We do have 6, so we write down 6. We have 7, 8, 9. Even though 7 appears twice, we just write it the one time. We don't have 10, but we do have 11. We don't have 12, but we have a 13. We don't have 14, but we have a 15. We have a 16. We don't have a 17, but we have an 18. So like I said, just every number that we see at least one time we write down in the union. So this one here, this symbol was our intersection. In your intersections, only numbers shared by both sets. So one of the things both of these would share is they both had a 7 and they both had a 15. So those are the only two numbers that are shared. Okay, so you have only one problem that's like this, so you have to do a union and an intersection. And usually I find like the biggest problem is it's not that you guys don't know what a union intersection is, it's just confusing them, putting the wrong one in the wrong place. And then this one with the 3 sets. So for time's sake, I took this one out. So this one's gone. So you only have to worry about 2 sets, not 3 sets. Because frankly, if you could figure out how to do a union between 2 sets or an intersection between 2 sets, you could figure out 3 of at some point. Okay, I'm going to quickly look this one up because I can't remember exactly what I did for the probabilities. Okay, so I thought, so this is kind of combining 17, 18, 19 together. So I'm just going to use one of these. So if we have something like this, so we have this set here that is grades and gender. So we broke up people over grades and gender. And we want to know, what is the probability the student just got an A? So if you look at this, we know that we have 49 students altogether. And then the A's, remember we got 10 women or 10 males with an A, 7 women with an A, but right here gives me the total. So all that is just 17 over 49. That one doesn't reduce, we'll just leave it like that. So I could also ask you something like, what's the probability of having a male? Well, we still have 49 people. And if we have 21 are male, this is one that can reduce, so sometimes they will be able to be reduced. So anything that could be reduced, I reduce. But just as a reminder, both this number and this number are divisible by 7. So if I did that, I'm just left with 3 over 7. So probability of male is 3 out of 7, or whatever that is as a percent. Something crazy, about 43. So then there were probabilities. So there were 2 kinds of probabilities. I gave us the easy one and the harder one. So I figured most of you would get the easy one naturally. It's the harder one I'm expecting some struggle on. But what if I asked you the probability that students got an A or a B? So this is a case where these do not overlap. So there is, I'm trying to remember if we use mutually exclusive, but these are disjoint. I remember that was one of the terms we used. We can have students with A's, we can have students with B's, but no students have both. So we're just assuming like this is one class. You do not have an A and a B in one class. You either have an A or you have a B as your final grade. So in that case, we just need to figure out probabilities of A's and add to the probabilities of a B. So probability of A was 17 out of 49. A B was 13 out of 49. So that is going to be 30 out of 49. double checking that. So this was like one of the problems you had in here. You had one exactly like this one here. Was the probability of getting an A or the student was male? So let me erase some of the stuff on here. So in this case, we're dealing with a situation like this. We have students with A's. And we have students that are males. And we have students that have both. So the disjoint was we don't have a student with an A and a B. Here we can have a student can be male and have B. So in this case, what we did is the probability of the first situation, they just had an A, the probability that they were a male, and then we removed the probability that they were a male and have an A. Or sometimes I said that this was the probability of the overlap. So I'm just saying this is where these two groups overlap. So I'm going to just change my color here so we can see it a little better. So for the first part, the probability of having an A, we already know that is 17 out of 49. Probability of a male, I'm actually going to use this one here to make it easier to add up later. 21 out of 49. And then we have 10 students who are the ones we counted as students having an A and students that are being a male. They're part of my overlap. So I remove those 10 students in my overlap. So altogether, we got 17 plus 21 minus 10 over 49. Finish that one over here because I ran out of room. So we're beside 29. 28, sorry, miscounted. Yeah, 28. So we end up 28 out of 49 are students who were A's or B or male, sorry. So I kind of tweaked it a little bit because this one wasn't appearing in a grid like this, but I know that one's an easier one to get. So I kind of threw that in there to kind of boost the grade in that particular probability question. There. I'm just going to put this up again. I get two computers here, so once I can see your exam, make sure I don't cover something we didn't need. All right. Mean, median, and mode. How do I have? So 20 is a mean, median, mode problem. So remember, if you do the mean, that means you're going to add up all the numbers. And then we divide by how many we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So we'd have 35 plus 11 plus 15. You know, I'm actually going to cheat here really quick because I'll be here all day otherwise. 201. The top should add up to 211. And I tried to give you something much smaller. So let me see, 1, 2, 3, 4, 5, 6. I think it's like 10 numbers again, except they're much smaller numbers like 1, 2, and 3. So if you had to add it by hand, you should be able to do it. But like I said, we do this because we're dividing by 10. I just moves 1, so it's going to be 21.1. When we do median and mode, my suggestion is always reorder data, definitely for median, and it does help with mode. So that means we want to start from smallest to largest. So my smallest number is an 11. I have 11 again. I have 11 a third time. Then I have a 12. I only have one of those, it appears. I only have one 15. And let me see, then the next smallest number I have is 27. We have 2 of those. Then we have a 28, a 34, and a 35. So because we know we had 10 numbers, I always suggest when you reorder, just count to make sure you still keep the same amount of numbers. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is just a way to just double check that you didn't make a mistake and miss something you needed. Because occasionally you like miss out a number in here, and counting it will let you know that you missed it. So median is the net data in the center. That's why we reorder it, because we want the data in the center. So if I count down to it, just taking off one number at each end until I end up in the exact center, we end up with 2 numbers in the center. So 7, 8, 9, 10, 11, 12, 4, 42 over 2. So we end up with a 21 here. So I just took the average of the centermost data. So remember, if you have an odd size data set, then it should just be one number in the center. Mode is the one that repeats the most often. You could have more than one. You could just only have one, but we see that the number that repeats the most is 11. Because 27 only repeats twice. That's the only one that's a competition at all. So in this case, it just is the 11, because that's the one that repeats the most. And also as a reminder, mean, median, mode could be equal, so, or some of them could be equal. So if like you get one of your medians is like 5 and then you find out your mode is 5, you didn't make a mistake probably. It's just a lot of times they'll come out to be the same. And sometimes you get really perfect data that they all come out to be the same. I'm going to skip a few of these questions and I'm going to come back to them. This stuff seemed to be the, as far as I can tell, you guys handled the easiest. So I want to just go to the linear equations, go through that, make sure we have the time for it. And then we'll go back to the ratios, rates, and percents. Oh, I forgot we had solving equations too. Yeah, that's what I wanted to do here. So they're solving equations. So they're solving the linear equations. There was find the equation for a line. I don't make you graph a line because it's really hard to do it with a Canvas to make it does that. So that's the one thing I didn't ask you to do. So just run through the solving here. So I've kind of escalated it, I believe. How many did I have solving? I only have one, looks like, because it was something we already tested. So if we need to solve what we said is we always wanted to try to isolate your x to one side and everything without an x to the other side. So we only have one x, but we have two numbers without an x. So I'm going to subtract 2 from both sides. So that I can basically get rid of this 2. And then in this case, I have 9x. I want to get rid of that 9 because it's multiplied. I have to divide to get rid of it. So we're left with x is -6/9, or you'd say x is -2/3. So if you end up with any fractions, once again, they should be simplified fractions. So if we ended up with a case like this, where we had multiple of our x's or something like that on one side, we would first add like terms. Because then we're going to get down to 27. 27 is like the apex of what we did. So in that case, we have 12x minus 11x. So that should leave me with an x. And then we still just have that 15 by itself over here. So we just add like terms on one side and the other side. Then I can now add this 15 over here because minus 15 plus 15 cancels out. And I'm left with x equals 27. All right, so for this one here, when we had parentheses and all that, we wanted to distribute. First. So we just keep distributing here. So -3 times x is -3x, -3 times -2 was +6. And then we just keep that 5 here. So we're just getting rid of the parentheses. -8 times x is -8x. -8 times 5 is going to be +40. At this point, then we add like terms. So it's really over here we have like terms. So we got the -3x, and then we have a 6 plus a 5. The 6 and the 5 are the like terms. We add those together, that's an 11. So just so you know, this one, a lot of these come out as fractions in here. It doesn't mean your whole test is fractions. So we want to put my x's together and my non-x's together. So we like to put all our x terms to one side. So it doesn't matter if I try to add the 3x to both sides or the 8x, just pick one of them. I'm going to add the 8x. So that means these ones cancel out. -3x plus 8x leaves me with 5x plus 11 equals 40. You go up here to finish. So from here, I just -11 from both sides. So then my 5x is all by itself on one side. The other side we have 29. We're going to get x is 29 over 50 after we divide both sides by 5. Let me add that division in there. So as I said, don't expect everything on your test to be fractions, though. It just happens to be that Lumen really likes fractions. I did not write anything as decimal responses for the most part. I left it as fraction responses if we ended up with anything like that. Like I said, you have one solving problem. I believe we did do some testing on that, which is why I just kind of tried to lower it to one of them. So this is the stuff that we had the least amount of testing on, because I don't think we did any kind of testing on this, to be honest. I didn't do the question like this, because being able to identify points is something that we're going to have to be able to do a question like 28 or 29, sorry. So 28, you can go through it, but like I said, I don't have a question exactly like 28. I have one like 29. Or it's a combination of 29 and there's one other one here, and 33. Just check, see if there's one more like it. So 29 and 33 kind of get you in the same place here, but let's say we wanted to find an equation to this, which is basically what 29 is saying. Well, this one came out nice. If we want slope, all we really need essentially was, there's two ways to do it, but one was to find 2 points. The other way was to do it with a triangle that we've been doing. So with 2 points, what we're looking for is 2 points I can definitely record. This is why I didn't do 28. So this point here is x is -1, y is 4. And we'll pick, I don't want to pick that point because that one's going to be confusing. Yeah, I guess I'll have to pick this one. It's just the problem that it gave me. This one is a +1 -4. So we label these points x1, y1, x2, y2. And slope was just going to be your x2 minus, sorry, x2s, y2s. It's going to be your y2 minus your y1. I'm trying to get my y's to look like y's. There we go. And then x2 minus x1. So we said that y2 will be -4, and then we subtract the y1, and the y1 was a +4. Then we do the x's, and we said x2 is 1, and x1 was a -1. A second, there's something I don't like about this. I think I switched number. -1 and 4. Got one of my negatives off here. I'm trying to see which one. Oh no, I'm fine. For a second, I thought one of them was off. So we got -4, -4, -8. 1 minus a -1, so that's 1 plus 1. So my slope is -8/2 or -4. Then if you wanted to do this with the triangle, that was, once again, we just found 2 points. We made a triangle between them. This is your x, this is your y. So my y from this point to this point goes down by 1, 2, 3, 4, 5, 6, 7, 8. My x is going to always be increasing, but it goes up by 2. So slope was always the change in y over the change in x. So in this case, it's going to end up being a -8/2 again, and we get the -4. So if you do want to have an equation for this instead, like I said here, equation, remember y equals mx plus b. B is your y-intercept. So we see that we cross the y-axis here at this point, at the point 0, 0, so x and y. This one here is your b. So it's always that point where you cross the y-intercept. So this would be y equals negative 4x, in this case, plus 0. Just checking one thing here. Right there it is. We also had talked about horizontal and vertical lines. So this is the line x equals negative 4. So what this is going to be, it's going to be a line that passes through negative 4, because what we want to make sure is that I pick any point. Doesn't matter what y is. So this would be 1 minus 4 is that your x is always going to be negative 4. That's all we want to make sure. So this gives us a horizontal line whose slope is going to be undefined. Because if I took those 2 points to find slope, I have 4 over minus 4. And then I'd have 1 minus the minus 4. So I end up with a 3 over 0. So that's why it's undefined. Because you always end up with a denominator 0. The second one, that's going to be a horizontal line. 1, 2, 3, 4. So it's going to be a horizontal line that's going to pass through y equals 4. So once again, if we pick any kind of points here, this point is going to be 2, 4. This point would be minus 3, 4. But what's important is all the y's stay 4. And in this case, if you do slope, this one should end up being 0. Because the top's going to end up being 0, which in this case just equals 0. So you can't have 0 on the top, that's fine. You can't have 0 on the bottom, that's what makes it undefined. Okay, so I'm going to skip 31 because I don't ask you slope directly. I ask you questions, like I said, like 33 or 32, where I ask for an equation. I don't ask necessarily for slope. So 32, this one gives you a point. So you have an x1, y1, and it gives you it gives you a point, x1, y1, and it gives you a slope, 6 over 7. And we have this equation that helped us find the slope of a linear equation. And this was what we called point slope form. So what we did here is we say that y1 is going to be that 8. So we keep this y. Why change the purple here? Oh, so I can show this. So we're going to change that one here. So we have y minus 8. My slope, we said, was going to be 6 over 7. And then we keep the x. And that's the x1 that's going to be this other point at 21. So I believe this is much messier than what your actual test is going to be. Actually, that doesn't turn out too bad. So 6/7 times 21 should be 18. You get something like this. We distribute first after we get to that equation. Then after we distribute, we can add this 8 over here. And then we're going to end up with a point slope form. So we get y is 6/7 x minus 10. So we had another form of this where we were actually given 2 points and we have to do the same thing. So we're given 2 points. We just have to find slope. We're going to do everything here the same. So like I said, I'm going to skip 33 because we kind of did a sort of example of that. Just, you know, for time's sake, I did take out a question like 35. So we'll have to question like 34. So this case, we have 2 points. And we want to find the equation of the line in this form. So the first thing we need to do is find slope. So we are going to go through it and label these points. Once again, it doesn't matter which ones I label what. So this could be x1, y1, x2, y2, or I could have labeled them the other ways. That would have probably been easier. So slope, once again, is going to be the y2, y1 on top, x2 minus x1 on bottom. So I get 5 minus a -4 on top. And then I end up with 0 minus 9 on bottom. Oh, yep. Okay, that's what I'm going to get. So this one happens to give me a slope of, so I should end up with a +9 on top, a -9 on the bottom. I'm just double checking. Yep, that's what it is. So we end up with a slope of -1. So this is my m, and we said this is my x1, y1. So we can use this equation again, because we do have everything labeled. We keep the y, but y1 is -4. So we subtract a -4. Slope is -1. And then we get x minus, and my x1 is 9. So this is y plus 4. We get a minus x here, and then if I distribute to both numbers, that's going to be +9. We're going to subtract 5 from both sides. I'm just taking a quick look here. Oh, because we had 4 here. I don't know why I said 5. It was 4. Because I was already thinking ahead to what the answer was. +4. So we subtract 4 from both sides because I knew we were going to have -1 plus 5. That's not ahead of myself. Okay. So I'm going to go back and I'm going to do the ratios to kind of explain. I did a little bit of changes to kind of make this work a little smoother for us. So there was one question that I got a couple answers on that had to do with rates and fractions. Oh no, sorry. It was ratios and percents. Just let me go back here and find it. Okay, so I'm going to do one like 21, but I'm going to do 22 first. So a ratio. No matter what you get, it's always going to stay in a fraction form. So we got the American Association of Colleges found that 95 out of 100 full-time students balance their studies with full-time or part-time employment. So the ratio is 95 over 100, which actually reduces to, we divide both by 5, we should end up with 19 over 20. As a percent. Now, we already said we got this fraction of 95 over 100, so that tells me right there, that represents 95%. So like I said, there was a little bit of confusion on that one, and that's because when we write a ratio, we always write it as a fraction. A lot of the ratios that we did in class were something similar to, we have like 3 girls to 12 boys. This was one we did an example of. So I did a ratio of boys to girls. You'd end up with 12 boys over 3 girls, which turns into 4 over 1. You'd still keep your answer as 4 over 1 if you're talking about a ratio. So rates. So if you have a rate problem like this, so a 24-ounce bag of shredded cheese costs $2.16. What is the cost per ounce? So when they tell you cost per ounce, you know cost goes on top, ounce goes on bottom. So the cost was $2.16 over 24 ounces. So we end up with a 0.09. And because this is going to be cost per ounces, this means that if the cost is 9 cents per every ounce. We have one like 22 there, so I try to make it easier. So I have one of them that looks like this. I was hoping that would avoid some of the confusion. So you do have one where you're comparing to the whole, like this ratio does, and then this one was comparing to a part. And then I have one like this one. And I put the units on there to make sure that you get the units right. Like, is my unit ounces per dollar, or am I doing dollars per ounce? Just to make sure you get that part correct. And then, yep, that's what the last 2 questions are going to be here. Then our last few things is we did a little bit of finance math. So for the finance math, I have a question like 23 and 24, kind of a little tweak. So you got to be careful what you're being asked. Because if you look at this one, sales tax in the state of Arizona is 6%. We want to know, what would the sales tax be on a $2,200 car in Arizona? So they're not asking for the total cost of the car. What they want to know is what 6%. So remember, you always write your percent as a decimal. Like I said, it was 23 and 24. I think the biggest issue is just make sure you read it and you answer what you're being asked. Because sometimes you're asked for like a discount or the taxes, and sometimes you're asked for a total. So taxes were $132. What would be the final cost of the car, including tax? Well, in this case, it's the cost of the car plus the taxes. So it'd be $2,332. I think I have one similar, except that it's a, let me see, what do I have? Oh yeah, I think I did switch around. I think I have a car one. It's just you're not finding taxes on that one. You're figuring out the discount. But I do have one where you're calculating taxes and one where you're finding a discount. So 24 would be a discount. So you have given this information, find the new price, round to the nearest percent. So the original cost of the item is $25. The discount is 21%. So if I do this times the 21%, you get 5.25. So this is dollars. This is the discount. So when you're trying to find the discounted price of this object, what you're doing is you're going to take that 25 that you originally paid, and you're taking off that discount of $5.25. So you're actually paying $19.75. When I think it got rid of the wire.